All right, so here we're going to take a look at solving system, or what are systems of equations, right? Now, first some notation, just general notation here for a system of equations of n variables will look like this, right? So it's good to just get an idea of the abstraction of our system so we can refer generally n variables, right? And these, so what we have here is a system of equations that has n variables, and this particular one, n equations. Right now, it doesn't always have to be the case where we have the number of variables matches the number of equations. All right. Sometimes we will have more equations than we do variables, or vice versa, and we could still attempt to solve them. They may or may not have unique solutions or solutions at all. But just here, if you notice here, the subscripts, the way we'll name these, right? The first subscript in the variables x, right? So it just refers to the number of variables, x1, x2, etc., as opposed to the convention x, y, z, because we will quickly run out of letters if we use those. So we stick to using x1, x2, x3, etc., depending on how many variables we have, right? Now, in terms of the coefficients that we reference, that first subscript, so the 1, 1, the first refers to what equation it comes in. And the second one refers to, well, what variable is it attached to, right? So all in our first row, all of them are A1 something, right? 1, 1, 1, 2, etc. till we get to the nth one. All right, all of them in the second equation, the first subscript is 2, right? 2, 1 for x1, 2, 2 for x2, etc., etc., right? These are not powers, subscripts. It's a naming convention. All right, so this is what our systems would look like. Right now here, let's take a look at, I'm going to look at 3 different ones. And we're going to take a look here at how each one of these are different. All right, so if we look here at our first system here, where you have x1, x2, x3 equals to 6, 2x1 minus x2 plus x3 is equal to 3, and x1 plus 2x2 minus x3 is equal to 2. All right, now this system of equations has a unique solution, and that unique solution is given here. All right, now a distinction here is that the order triple, 1, 2, 3, right, that is referring to x1, x2, x3. This ordered triple, excuse me, not pair, is the solution. And then when we use the curly brackets itself, that's what we call the solution set, right? So this here is our solution. And then this here is our solution set. All right. And this first example here is one that has a unique solution. All right, so let's take a look graphically what that looks like, so we can kind of visually understand what this means. So I'm gonna switch over here to our 3-dimensional calculator here, graphing. All right, so what we have graphed here is we have 3 planes. All right, you see these 3 planes, they go off in different directions. All right, they infinitely expand right here. They're just kind of, we're restricted by our screen here, but they go off in their each individual directions here. Right, they're not parallel, right? They're not even perpendicular to each other, but they do intersect, right? And this is in the case where we have exactly one solution, a unique one, and you could see it there, right? That point A is the point 1, 2, 3. Okay, so now we could see here what a system that has a unique solution looks like. All right, now if we look at our second example here, right? So for this equation, or system of equations here, right? x1, x2, x3 equals to 4, x1 plus x2 equals 2, and then 2x1 plus 2x2 plus x3 is equal to 6. All right, now if we look here, the solution set, right, it's everything encapsulated by those curly braces. it looks a lot different here, right? Now, what this is telling me is that I have an infinite number of solutions. All right, and the solution set is telling me how to find, if I just said, give me one of these solutions, right? It tells me how to do that, right? That's what this set builder notation is telling me, right? So what this set builder notation, which is representing the solution set, is telling me, all right, the solution consists of an order triple that follows these rules, right? Where t is any real number. So if t is any real number, let's choose a simple one. T is equal to 0. All right, so if I do that, plugging 0, I get 2, 0, 2. Okay, and that is a solution, right? That's one solution. And the solution set encapsulates all of them, which in this case is an infinite number of them. So here, let's take a look here. All right, so if I turn all right, now here, now you see here these planes, not parallel, right? They all go off in their different directions, but they have intersection in common. Now it's different than our first one because that intersection was a point, right? Here, what we can think of here is this is actually a line, right? If you look here, right, that line is common in all three planes. So our solution set consists of that line, right? And the line is an infinite number of points. And that is what our solution set that we had was indicating. And if we see here, when we chose a value for t being 0, we came up with the point, what? 2, 0, 2. All right, and you can see that is one particular solution. All right, and you can see it, it's on the line, it's on all three of the planes. Right, it is an instance of one solution. And the line itself represents all the solutions, right? And again, the line and the planes go infinitely off in both in their directions, right? Here it's just a little snippet of what we're looking at here. All right, so that is the second case, right? So there are three cases that we're going to be that are going to arise when solving any system of any number of variables, right? There will only be three possible types of solutions. We'll have a unique solution, an infinite number solution, and then the third possibility is this no solution, right? So if you look at the way the solution set is written, that little 0 with a line through it, this is telling me that it is empty. It's the empty set. So that's telling me that there are no solutions. So if we look here, turn these off here. All right, so if we look at these here, I see one here. All right, there it is. All right. So what we have here is that those first two equations actually represent the same plane. Right, and then that third one is another plane, but it is parallel to the other two. So in this particular case, even though two of them are the same, the third one is parallel. So there are no solutions here, right? And that's graphically what it would look like, right? Now the graphs are good kind of visuals to help us understand here, but just keep in mind we won't always have this, right? Especially in higher number of variables, and we just don't have ways to visualize something in 5 variables. Okay, so just keep that in mind. But they're nice to kind of gain an intuition of what that looks like.